And then after class, like I said, just always give me like an hour or two to upload the video. It's not me that takes that much time, to be honest. It's YouTube. Anybody ever upload a video to YouTube before? No. Well, it's super easy. All you do is upload it, right? But then um it goes through this whole processing thing where it just converts your video to like a YouTube format thing. And that, depending on how long the video is, uh it can take anywhere from like 15 minutes to 2 hours. So that's what I'm always stuck with, is I'm always waiting for something else to happen. All right. So adding integers. Adding integers, very simple. Okay? This is the first time that we're actually going to see a lot of rules. Okay? So let's think about a super easy problem. How about this one? Uh-oh, I hear a lot of beeping. The last week they've been completely redoing my road. Like repaving it and everything, so I hope they're like gonna be finished with it today. So here's a really easy example. Does somebody want to give me the answer to that? All right, Steve, I know, great. I mean, brain busting questions here at 8 o'clock in the morning on a Wednesday. But now, if I asked you to, instead of just telling me what the answer is, can you describe what the answer is? I think, or better yet, can you describe the process on how you did this? I think a lot of us will come up with this right here. Well, Mr. Float, you have 3 objects in the first. You have 5 objects in the second. And when you push them together, you have a total of 8 objects. I completely agree with that. In fact, I think that is not only one of the best things to do, but it's the easiest to show your children how to add numbers. And if you think about it, kids, gotta be honest with you, are learning constantly. Even little ones. Like if you think about it, they are doing statistics at 2 years old. Now, if you don't believe me, the first thing you do in stats is collect data. The second thing you do in stats is you start to organize it. Kids will collect their favorite toys, and then they organize their toys based off some common characteristic, like their favorite color or their favorite superhero, and they bring all of them together. They are doing statistics at 2, 3 years old. It's just, do you recognize it? Do you recognize that that's what they're doing? Maybe you do, maybe you don't. I didn't recognize it until I took a stats course. And then my sister started having kids. And I was like, oh, wow, look at that. CJ's doing stats. And my whole family's looking at me like I'm crazy. And then I explained it. I was like, that's what he's doing. He's organizing. He's analyzing. Pretty soon he's going to start concluding things, which is what you do in math. So there is something that's really fascinating happening in this problem. And here's what it is. Let me show you. Another way that we can describe this, simple addition, is this thing called a number line. I use number lines a lot. I think they're really easy to draw and they're really easy to see what's happening. First, we read left to right, so the first thing I see is that number 3. So I'm going to pretend that I'm standing at number 3. Second thing, reading left to right, it's 3 plus. Well, this tells me to move to the right because I'm going in the positive direction, so I'm going to move to the right. And then the 5 tells me how many units I need to move. 1, 2, 3, 4, 5. So now I'm standing at 8, and that's my answer. Now, I want you to think about the next problem the same exact way with this number line, and I want you to tell me what it is. So here's your example. -4 minus 6. -4 minus 6. Tell me what you get. Jillian, you have your hand raised. Are you gonna? I'm sorry.
Do you want the answer?
Sure, I'd love the answer.
Is it -10?
I love it. Now let's see why. Okay. So if I do the same exact thing that I did before, I drew this simple little number line. What this is telling me here is, okay, you're going to start at -4, which is to the left of 0. That negative sign tells me which direction am I moving, right or left? Yeah, I'm moving to the left. How many units? 6. 1, 2, 3, 4, 5, 6. So now I'm standing at -10, and that's exactly what Jillian gave us. So if I zoom out and I show you these two problems, I'm going to rewrite them again over here. 3 plus 5 and -4 minus 6. There is a pattern starting to develop here. Okay, there really is. Mathematics is the study of patterns. It's what we try to do with everything. And the reason why we try to find patterns is because patterns allow us to predict things. And that's what math, we really try to do with math. We try to tell a future with it. All right? Does anybody see a pattern? Does anybody see anything common between the first and the second problem here? And I'll give you a massive hint. And this is like me in the middle of a dark room and I'm trying to throw a dart and hit the bullseye. All right? So I'm sorry if the question is very vague. But there is something that is common between these two problems and it has to deal with the numbers themselves. Anybody see it? Think about the direction I was going in each one of them. In the first one, I went to the right. The second one, I went to the left.
Right? Like 0 is the common? Is that what you mean?
No, zero's not common. I just write 0 because it lets me know where I'm at on the number line.
Oh, I thought you meant common between these two. Okay.
Yeah, no, I'm like I said, this question's very vague. It's very vague. Maybe I didn't even ask it properly or correctly. So I'm just gonna give you the answer because I don't want us to, like, oh, what's going on here? If you look at the sign of the numbers on the 3 and the 8, they're the same. They're both positive, correct? If you look at the signs on the 4 and the 6 in the second example, they're both negative, correct? When that occurs, you add the numbers. Think about it. 3 and 8. Oh, sorry. 3 and 5. 3 plus 5 is 8, correct? Look at the 4 and 6. If I didn't tell you those signs and I just said combine the 4 and a 6, you would say 10. But if I make them both negative, then the answer is -10. And that is our first rule with adding integers. So let me write the rule down and then we'll internalize it. Rule number 1. And I'm gonna be a little bit more vague than your book. When combining integers. Rule number 1. If the signs on the numbers are the same, and that's huge. So we're going to underline that. Then add the numbers and keep the sign. Okay? Because here's what's nice. If our problems are always these very small numbers, okay, then we can always do a number line and just draw a little stick figure and Make them walk up, back and forth on the number line. But the problem becomes, what if the numbers get large? Do you want to draw number lines your whole life? No, you want a rule that kind of simplifies everything. So with the first rules, here's what we're saying. When you have two numbers or more, but let's just go with two. If the signs of the numbers are the same, then you're going to add the numbers and keep the sign. And this is your very first introduction, honestly, on how to study math. Because remember, I told you at the beginning of the semester, I'm gonna teach you how to study math. I'm putting a real big star. Because mathematics is not about doing example problems over and over again. It's not about just looking at your notes and replicating what we did in class. It is about understanding a rule and then applying it to a problem you've never seen before. For example, you've never seen this problem before. And that's okay. You have a rule. And the rule says, if the signs on the numbers are the same, then add the numbers. A lot of us have been in this situation before where you're given consequences. If you do this, then this will happen. Am I right? Usually it's when you get yelled at by your parents. If you go outside with them, don't come back. All right? I think an easier example is, if it's raining outside, then you'll get an umbrella. Well, math is the same thing. You always have this first part, which is the if statement. And this is how you study math. You learn the rule. You learn that sentence. So you always have the beginning part. Now, this is called a conditional statement, and the first part is called the antecedent. This is not an English nor logic course, so I don't care if you know those names. What I want you to know is there's an if part. And that if part is the thing that you're trying to look at. All right, because like I said, you've never seen this problem before. Now, if you meet this condition, the signs of the numbers are the same. Well, let me ask you a question, everybody. The 48 has a negative sign in front. The 31 has a negative sign in front. Are the signs the same, yes or no? Since we say yes, then we're going to add the numbers and keep the sign. So according to this rule, what I'm going to do is I'm going to keep my sign. Since both numbers are negative, I'll keep the answer negative. And then off to the right, I'm going to add them together. 8 and 1 is 9. 4 and 3 is 7. So negative 48 minus 31 is negative 79. And that's as hard as it gets. That's how. Now think about this. I gave you one rule. How many different problems do you think I can come up with? How many numbers exist? An infinite amount, correct? So all you got to know is this first rule. That's it. If you know this first rule, you could do any problem. Let's look at this one. Negative 432 plus negative 399. Now, the way we approach this, we look at the sign in front of the number. The 432 is negative. The 399 is negative. So let me ask you the question, and I want you to look at the top of this screen. Are the numbers the same sign? Yes.
Yeah.
As soon as you say yes, Ashley, then add the numbers, keep the sign. You already know your answer is negative. You already know that. The question becomes, what is 432 plus 399? Well, 2 and 9 is 11, carry the 1. 3 and 9 is 12, plus 1 is 13, carry the 1. 4 plus 3 is 7, plus 1 more is 8. So the answer is negative 831. Does that make sense, everyone? Now, visually, what's happening here is you're on that number line. You're starting at negative 432, and then you're moving to the left 399 spots. And when you stop, you're going to be standing at the number negative 831. How are we looking so far, everybody? Is it as hard as what you thought? It shouldn't be. But I guess now we need another rule. Because hopefully, at least one of you is sitting there in internet land and going, well, what if the signs are different? Kim, were you thinking that? No, you weren't thinking that? Are you thinking it now? All right, so here's our second rule. So let me write it down and then we'll explain it. You know what? I'm going to do it like this. Because I think we learn better with steps. And then once you see it in action a couple of times, it gets much easier. Go ahead and write that down. Normally, I would just write this in a sentence, but I think if I break it down in little steps, it'll make it much easier for us. It looks like, oh, what is going on here? It is very simple. It's going to go very fast. I just want you to see what's happening. That's all. Okay, so here's our example right here. Negative 398 plus 151. Now, first thing we look at, signs on the numbers. So, the 398 has a negative symbol in front of it. The 151 has a positive sign in front of it. So the signs are opposite. So if the signs are opposite, then we're going to do this. So let me show you what I mean here. And once we do this maybe like 5, 6, maybe 10 times, you're going to just go, "Oh, I know exactly what to do now." So you can kind of shorten it a little bit. So step 1, we're going to find this, in quotation marks, this larger absolute. What I mean by that is this. Off to the right, I'm going to write step 1, and I'm going to find the absolute value of each of these. Now, last time I checked, the absolute value of negative 398 is 398. Absolute value of 151 is 151. So my 398 is considered the larger number. So that's step 1. Step 2, all you're going to do is subtract. Large number minus small number. So, step 2, 398 minus 151. Well, let's see. We get a 7, a 4, and a 2. So I know numerically my answer is 247. The question becomes, what's its sign? Well, if you look at step 3, it says keep the sign of the larger number from step 1. Well, what was the sign of the larger number? It originally was what?
Negative.
So your answer is negative 247. Does that make sense? Okay. It's not a lot of steps, but once you start doing this, your steps 1 and 2 become very small. Like you can kind of just start breezing through it. I don't know if anybody's ever showed you this. Anybody ever show you to do it like this, or were they like, "Oh, you just do it this way"? All right, so I break things down a little bit. Let's try another one. Yeah, let's do this one, and I think it may drive the point home. All right, very simple problem. Negative 3 plus 6. Okay? So I'm going to do it the steps, and then I'll show you a picture. Step 1. Let's find this larger absolute thing. Absolute value of negative 3 is positive 3. Absolute value of 6 is positive 6. So that's going to be my larger value. So now I subtract. That's step 2. Larger number on top, smaller number on the bottom. 6 minus 3 is 3. Step 3, I keep the sign of the original larger number. And what I mean by that is this 6 right here we deemed was larger, and that 6 inside the absolute value is positive. So I know my answer is positive. So negative 3 plus 6 is positive 3. Visually, here's what happened. If I read this from left to right, I'm starting at negative 3. The plus sign tells me move to the right, and that 6 says move to the right 6 spots. 1, 2, 3, 4, 5, and 6. Now I'm standing at positive 3. So I crossed over 0, which separates negatives and positives. So do you see how this works? Are there any questions? All right. So I need to be honest with you. Section 3.2 and section 3.3 are done. So we did 2 sections in about 25, 30 minutes. Okay? So what I want to do from now until the end of class, nothing but examples. Because I think what we need is just a lot of practice. And there are a lot of different types of examples. So even though I said we're done with section 3.2 and 3.3, we're going to be doing a lot of examples from both. Okay? So I'm going to give 2 problems. I want you to do them for me, please. All right, so try those 2. All right, what'd you get for the first one? 15 minus 6. 9. I love it. Did you have to go through all that mess that I did earlier where you had to like find the absolute value of each and stuff like that? Or did you just look at it and go, 15 minus 6 is 9?
I just kind of looked at it.
Yeah.
Just because those are like smaller numbers. I feel like it'll help with larger numbers.
I agree. So, like I said, you're gonna be able to recognize things where you're like, oh, that's just 15 minus 6. That's like you got $15 in your pocket and you went to one of Professor Float's favorite restaurants, McDonald's. I love 20 nuggets, large fry, large Coke. Since I'm recording, I'm not going to tell you how I eat my French fries. I'll wait till I'm off the recording. That way I don't feel bad about myself. All right? But you got 15 bucks in your pocket. You buy $6 worth of McDonald's. They hand you back $9. I mean, that's pretty straightforward. The second example, though, is a little bit more difficult because the numbers are a little bit larger. What's nice, you have two rules, and those are the only two things that you need to understand, and I can give you an infinite amount of problems. So let's go ahead, let's look at the second one. We're going to find the absolute value of each first. 44 is definitely larger. So that's step one. Step two, let's just subtract. Larger number up top, smaller number below. I have to borrow. That turns into a 14. That turns into a 3. 14 minus 8 is 6. 3 minus 2 is 1. And since the 44 was deemed larger, I know my result is going to have the same sign as 44. So this is going to be positive 16. Does that make sense? Okay. Let's do a couple more. Let's do that one. Uh-oh. What do we notice about this one?
They're both negative.
Are you sure?
Doesn't it turn into a positive?
Are you sure? Notice,
They're,
I didn't say Lakendra was wrong. I just asked, are you sure?
I think
Okay, so this is the first problem where we need to be careful. Okay? We need to be careful.
I think the negative 481 stays negative, but then the 37 is positive.
Why?
Because you have a negative and a negative. I don't know how to explain this. See, like whenever I learned this before,
Uh-huh.
take the little parentheses and you just take the 1 minus, and I don't know how to explain it without like drawing it.
So you're saying this, right, Ashley?
Yes.
Yeah, that's what that's what a lazy math teacher does. I'm not lazy. Stevie likes me because I explain things. I'm going to explain. I'm going to explain the why right now. So actually, Ashley and Lakendra, you're both correct. I just wanted to hear you say, yeah, I'm pretty sure, yeah, or you tell me why. Here is why. Now, let me write out the next step, and then I'll explain why we get this. So the first thing you got to do is rewrite the problem. Now the question becomes, well, why? Here's why. On the right-hand side, I wrote parentheses, exponents, multiplication, division. I wrote our order of operations. So first thing I look at are parentheses. Well, inside the parentheses is negative 37. There's nothing else inside there, so there's nothing else I can do. I definitely don't see any exponents. But now I see multiplication and division. Here is why we need to rewrite that as a positive. That negative on the inside, in between the 481 and the 37, is kind of like a negative 1. And when you see two negatives back to back, what you're really doing is you're multiplying them together. So that's why you have to rewrite it as a positive first, because multiplication and division come before addition and subtraction. So what you're really doing here is... I'm sorry, Lakendra? Oh, I didn't hear you. Okay. So what you're really doing here is you're multiplying those two negatives together. And a negative times a negative, believe me, for now, is a positive number. I'll explain why it's negative later. Or I mean, why it's positive later. So that's why we rewrite it first. So anytime you see this back to back, you got to train yourself. Oh, that's multiplication. I need to do that first. I'm going to rewrite it as a positive. Does that make sense, everyone? This is the trickiest one right here. So now that we rewrote the problem, we can go ahead and apply one of our rules. So signs of the numbers are opposite. So I know I'm going to find the absolute values of each. $481, $37. Clearly, this one is the larger. So that's step 1. Step 2, we're just going to do 481 minus 37. I need to borrow. 11 minus 7 is 4. 7 minus 3 is 4. 4 minus 0 is 4. And I keep the sign of that larger value. Well, the sign was negative inside the absolute value. So my answer, negative 444. Does that make sense, everyone? Okay? How are we looking? Now, Stevie, I know you like pictures, so let me explain in a picture how that double negative thing works. Are you ready? I'm not going to draw all the little tick marks for a number line. I'm just going to do this. So if I read this problem from left to right, I'm starting off at negative 481, and then, and I'm going to do a different color so you can see it, and I want everybody to just look at the screen right now. Just watch the screen. You don't have to write this down, just watch. If I read this problem from left to right, watch what this tells me to do. It says, start off at negative 481. Boom. Then it's telling me, move to the left. But then this negative sign says move to the opposite side. Because remember, at the beginning of class, I said we need to think about the negative as an opposite, correct? So if I'm starting at negative 481, and that first negative sign is telling me go to the left, well, the second negative sign is telling me to reverse my direction. Which means now I'm going where? To the right. And those are positive values. Positive values move to the right. That's why we changed this to a plus. Okay? So you would move to the right 37 times, and you would be standing on negative 444. So you moved in the positive direction, which just means to the right. And this is why, and I said this earlier, when I talk to students taking physics, students have this idea that if you have a negative sign in front of a number and you're talking about speed, that you're slowing down. And the answer to that is no. You're just moving in the opposite direction of what I am saying is the positive direction. That's what a sign means. It means the opposite of. Okay?
And I understand, like, this was so perfectly clear until you explained it like this. So if the negative sign means to go the opposite way,
Yeah.
you're going to go the opposite way like 3 times. Because there's 3.
No. This just tells me where I'm starting. So I'm starting to the left of 0 at number 481.
Right.
Now, that means opposite, and that means opposite. Do you agree?
Yes.
Okay, now, do me a favor. Come on, just erase.
So I can see how you're going positive with that second one right here in the middle.
Okay.
The red one. But then since there's another negative sign, wouldn't you turn it around and go the other way?
Okay, well, hold on one sec, okay? Let me get that back. All right, you ready? If I were to ask you, Kim, where are negative numbers? Would you say they're on the left or on the right-hand side of 0?
Left.
Okay, so if I'm telling you, Kim, to start at negative 481, and then you see this sign right here. See where I'm circling? What direction is that telling you to move?
Right.
A negative tells you move to the right?
No.
You just said negative numbers are to the left, correct?
Yes.
So that sign is telling you to move where?
Left.
But what if I threw this in there then? So this is telling me move to the left, but then the second negative sign is telling me what's the opposite of left.
Right.
So then we're moving to the right.
Okay.
All right? That's why two negatives make a positive, because you're moving in the opposite direction. So instead of moving left, you're moving it to the right. You need to read this from left to right, not from left and then I'm going to start reading wherever I want.
No, I get this. I think about this money wise, but it's just the way that you just explained it makes, I don't know.
I made it harder for you, didn't I?
Yeah.
Wow. That's, now I got to think of a way to boy, I don't want to draw 481 objects. I don't want to do that.
No, you don't have to. I get this problem. I
Yeah.
understand this
Okay.
problem. It's more about the rules of the signs that.
Well, I think maybe it's because have you ever heard of the negative symbol in front of a number referred to as the opposite?
No.
And I think maybe that's why it's confusing.
Mm-hmm.
Yeah, I think maybe that's why it's confusing. Like the way when I read this, and maybe it's because I have a lot more experience, and that's not fair for you. Oops, sorry. Jeez, that's a big negative sign. When I read this from left to right, I see start at negative 481. I'm going to move to the opposite, which is left. But then that's telling me, oh, wait, you got to reverse your direction. And then go 37 units that way. Is that, maybe I did make this harder than what it is. Did I, Kim? Did I make this harder than what it is? It's okay. You can say yes.
No, it's okay. My husband gets frustrated with me too because I probably question.
Well, just punch him. All right. Let's do, what time is it? Ooh, it's 8:56. All right, let's do a couple more. We'll call it a day. The hardest part about all this is just trying to keep everything just in order. All right, so let's look at this problem right here. $140 plus negative 75 plus 67. So now I have three numbers that I'm combining. But nobody says you have to do all three at once. Why not just do two? So if I look just at these two numbers right here. If I look at these two numbers right here, you got 140 plus negative 75. The sign in front of the 140 is positive. The sign in front of the 75 is negative. So I know I'm just going to subtract these two numbers. So off to the right, 140 minus 75. I have to borrow. That becomes a 10. This becomes a 3. I got to borrow again. So 10 minus 5 is 5. 13 minus 7 is 6. So 140 plus negative 75 is positive 65. And then the plus 67 just comes down. Now, you just take 65 plus 67. We combine them because the signs on the numbers are the same. Add the numbers, keep the sign. 5 plus 7 is 12. Carry the 1. 6 and 6 is 12 plus 1 more is 13. So although there were more numbers, the rules didn't change. Pick two numbers, apply the rule. That's it. Does that make sense, everyone? All right, that's as hard as it gets right there. All right? So let me give you one to do, and then we'll call it a day. There you go. Try that one for me. Hey, buddy, you okay? All right. Anybody got an answer?
Negative 1,103.
Negative 1,103. Anybody else get that? All right. Let's just go left to right. First, those two signs on the first two numbers are opposite. So, off to the right-hand side I go. Negative 981, absolute value, and then 321 absolute value. Clearly, that's the larger number, so I'm just going to subtract 981 minus 321. It gives me a 0. 8 minus 2 is what? I forget. 6. 9 minus 3 is 6. Now, since this number was negative, I know when I combine these two numbers here, it's negative 660 minus 443. Now I look at these two numbers. Signs are the same. So I'm going to combine the numbers. I'm going to add them together, keep the sign. So I know my answer is negative. 660 plus 443. Well, 0 and 3 is 3. 6 plus 4 is 10. Carry the 1. 6 plus 4 is 10. Plus 1 more is 11. So negative 1,103. Stevie, I think you gave that to me, right? Good job. Excellent job.